Hello everyone. For this week's tutorial, I'd like to go over how MIDI works, including the amount of data it takes up, and how it is less than even an MP3 file. MIDI is an acronym specifically standing for Musical Instrument Digital Interface, and as the title suggests, is used for composing music in a more compact form. Although the downside to this is that it has many limitations that traditional audio does not, which I will go over in more detail later in the video. In particular, each signal in a MIDI data is made up of 3 bytes. The first is a status byte determining whether the note is played on or off. The second byte is a musical pitch from 0 to 127. And the third byte is the loudness of the note, formerly called the note velocity. Unlike WAV and MP3 files, MIDI limits you to 16 tracks maximum, aka 16 channels, with channel 10 especially hard programmed for percussion instruments. The channels all have instruments linked to them, and on the software I am teaching with, MIDI Editor, you click the small piano keyboard icon to change the specific instrument that you wish to use. Note that like with note velocity and pitch, there are only 128 instruments. The MIDI file itself does not actually play any audio, because it is simply a chain of digital commands that the computer reads. As such, the MIDI uses an external file called the sound font that uses a different sample for each instrument. Unfortunately, the samples are uncompressed much like a WAV file, so they will also take up large amounts of data compared to the MIDI file. As a consequence of how sound fonts work, MIDI will sound different depending on which sound font you listen with, which is not true with regular audio. However, ignoring the sound font, the MIDI in general is always programmed the same. By default, most Microsoft computers come with a sound font called Microsoft GS Wavetable Synth. Although there are programs you can download to change the sound font instantly, and download different sound fonts off the web. The default Microsoft synthesizer sounds very synthetic, but some sound fonts you can get off the web have very high quality that sounds almost like real-life instruments. In order to compose your own MIDI effectively, you should be well versed in music theory, which is why I taught music theory before teaching you how MIDI works. Now that I've comprehensively gone over how to work with music in a digital environment, I can move on to actually making the games starting next week, when I introduce you to the Scratch engine.
Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.